now. I'm gonna share the screen, and mostly I will show to you the videos which is available in the GS video YouTube channel, but I will also show you the lab manual. Okay, so share application or screen number. This is number 1, this is number 2. Okay, now you can ask questions. Don't worry about asking questions. You can. Anything that will help you to understand and prepare for the exam. Okay, so you can ask questions for anything that will help you prepare in the exam. So anyway, welcome to this online revision so that it may help you to prepare for the final exam in practical. Let's identify first which exams or which experiments will be in the final exam. Number 1, you will have objects in equilibrium. This will be in the final exam, okay? Now, if you're asking, there are 3 methods to find the unknown mass. We will use only method 1 by graph and method 2 by mathematical equation. What else is included in the exam? Rotational inertia is also included, okay? What we will do with rotational inertia is by disk and by mass and rod system. What we will not do is to find the inertia of the ring. Next, we have electrical resistivity. Only this part, because the DC circuit, Hadi, this one, we didn't do it this semester, okay? So we will do only electrical resistivity. There are 2 processes or procedures for that. Number 1 is resistivity or R versus length, and then resistivity versus the inverse of the area or 1 over A. We'll also do parallel plate capacitor, and in the capacitance experiment we will do only the capacitance versus 1 over D, or the separation distance inversed, okay? What else? Force. Finally, this one. We will do force acting on a current carrying conductor. So we will also do this one. Here, we will do only table 1. So table 1 in your manual will be the force or the magnetic force versus the current in the loop. We call it IL. Okay? So let's start with objects in equilibrium. Now, I want to point out something, okay? In all this experiment, Shabab, you have to make a graph in all these experiments. But one of them you have to graph by computer. So this one is graph by hand. That means you have to bring a pencil and mastara and a degree scale, okay? Rotational inertia is graph by computer or PC. The electrical resistivity is by hand, okay? Capacitor is by hand. And force acting on a current carrying conductor is also by hand. So all the experiment will have a graph, except that the rotational inertia, you will graph by computer, which makes it very easy, okay? So let's start with objects in equilibrium. Objects in equilibrium, I'm using the lab manual, okay? PDF copy. So let's go. I think that's experiment number 3 this semester. There you go. Objects in equilibrium. Now, the exam looks like the data sheet. So if you have your data sheet with you, it's actually much better, okay? You will actually understand it better. So in objects in equilibrium, for the exam, if you get this, okay, for the exam, usually you will get something like this in your data sheet, except that there will be a number in the objective, 1, 2. So that means maybe you have to write 2 objectives. If there's number 3, number 4, that means you have to write 4 objectives. On the right side of the paper, you will have the number of points. So for example, 1 point or 1 mark, that means all the objective is equivalent to 1 mark or 1 point. If you have 2 objectives, then you have to divide 1 point by 2. That means 0.5 or half and half. Okay. Now, do you have to memorize the objective for this experiment? No. As I tell all my students, it's not a good idea or a good technique to memorize everything and then just try to remember it in the exam. Instead, the best way to write the objectives in any exam is by understanding it. Okay, Shabab, if you have questions, just you can talk or you can chat. Okay, but just do it slowly. So here, I want to show you something in the book itself. Here is the objective, but the keyword, as we call them, or the important thing in the objective is actually written here. Let me just wait and select the highlight, which is this one, to study. Okay, what else? There is a second one, to find. If we go to any experiment by random, okay, I'll take Joule's equivalent. This is not in the exam, but the idea for the objective remains the same, to study. You see it? To study. What else? To find is not there, but to determine. Let's go to another experiment. Okay. Rotational inertia. This is in the exam. To study. What else? To measure. What else? To determine. All the objective in any experiment. Let's go to introduction. Okay. Definitely this is not in the exam. To be familiar, to study, to determine. Let's go to experiment number 1. Experiment number 1, velocity. It's not in the exam, but still, it is there. Okay. Yes, it is being recorded. Don't worry, I will upload it in YouTube and give the link to my students. Okay, and you can share it to yourselves. So again, to study, to perform. As you can see, you only need to understand the first keyword, or what we call the action word. We must write one objective. I already explained that. Okay, you must understand how to use the keywords. Okay, these are the keywords to make the objective. So let's go to our experiment number 3, which is in the final exam, objects in equilibrium. So how do you write the objectives? Let's start with the keywords. Okay, let me go with my typewriter and type the keyword. To observe, for example. Observe is a keyword or an action word for the objective. What else? To study. Okay, let me write the second keyword here. To determine, or you can say to find, or you can even say to calculate, because these are action words which we do in the experiment. So how do we continue with these action words in our objective? Now let me show you how. Okay, I'll get my pen and I'll write with my hand. So the first thing is you can use the title of the experiment here. That's the title, and it will be given in the exam. Of course, your paper must have a title. Okay, so Muhammad Al-Ajmi Abdulaziz Montishri. Sorry about I couldn't read it well. The first thing is the title is useful for the objective. So you can say to study objects in equilibrium. So as you can see, Shabab, without memorizing anything, you can write your objective. So if you ask how many you should write, should it be 2? I don't know. How many is the number there? Okay, that's how you will write it. Second, to calculate. Oh, wallah, I don't know what I should calculate here. You can get down on your exam paper. Okay, look at the objective. What do I need to calculate here? Force T1 and T2, you know, in the graph, this is T1 and this is T2. You don't calculate it because it's already given. The angle you read, that means objective 1, to study or to observe. Okay, what you need to calculate is this, the unknown force. So you go back to your objective and to calculate the unknown force. You can even complete, like for example, you can write by mathematical method. So the idea, Shabab, of writing the objective is easy. As long as you have the title, you have the parts of the experiment you can write. I'll give you another example before we continue, okay? So let us continue to another experiment, rotational inertia. How should I write the objective? Okay, let's go to the objective. Number 1, let's say you have to write 1. Okay, again, to study what? Rotational inertia. Okay, you can be specific to the study rotational inertia of disk because you are going to use disk. Or you can say to study rotational inertia of mass and rod because that's the shape that you have to make or to study. Okay, what else? Aside from studying, you need to calculate, you need to find, okay, to find the, you can say, moment of inertia of solid disk. Okay, you can continue that one. What else? Let's say you need to write 3. There is something else that you have to find. Okay, you can go to the calculation part, and in the calculation part, you can have your objectives from there. Okay, let's go to the mass and rod. Here, you have to find the slope of the graph, which is alpha. Now you have to be smart, okay? The alpha here is the graph of what? Velocity angular, which is omega. You have this in theory, okay? Versus time. So what is omega versus time? You have radian per second, or you can get it as radian per second squared. So alpha is actually called angular acceleration. Okay, angular acceleration. So that means in the experiment you have to make observation, you have to find the angular acceleration. So let's write it in our objective. You can say to measure, again, the keyword, okay, to find, to study, to measure. What are we going to measure? Alpha. What is alpha? The angular acceleration. The angular acceleration of what? Of, then you can write the shape of the disk or of the mass and rod. Clear? I hope that it is clear how you can write the objective without, Yani, trying to memorize everything. Because if you memorize, you can write the correct objective, but on a different experiment. If you write a correct objective, for example, you write this, to study under static equilibrium, but you will write it in capacitance, you will get 0 from there, okay? How many objectives you have to write? Again, as I said, check the paper, okay? If the paper has a number 1 and 2, that means you have to write 2 objectives. If there is only 1, you have to write only 1 objective. How many points? You will find the points on the right side of your paper, of each question. Clear? Let's continue. Apparatus. We will go there, Abdurrahman, to the errors, okay?
Teacher,
Yes, go ahead.
can you repeat how I can write objective without remember, because I come late just.
The session is recorded. My suggestion is just watch the recording, because if I repeat everything, Shawab, we have to fit in 1 hour only, okay?
Okay.
It is recorded, and I will send the link to, I will upload in YouTube so that I can send the link to everyone, okay?
Okay,
And you can share the link to all of your friends. Let's continue. So you have to write down the materials. Now the question here is how many materials you have to write. I cannot answer, because the idea is how many spaces available, okay? Like in this case, you have 6. Do you have to fill it? No, because I cannot tell you. It depends on the experiment. That's the only thing I can tell you. But in each experiment, I cannot tell you how many you have to write. So the idea is you have to check the equipment, okay? Now in the equipment, you will actually see, so this is the equipment for the objects in equilibrium. You will actually see that some of the equipment have the materials written on the equipment. For example, if you look down here, what's the name of this device? It's called degree scale. It's not Pasco, that's the name of the company. So degree scale, fine. I will go back to my apparatus. I can write it here, degree scale. Okay, you know that we know that we are going to use a board. What else? We know that we are going to use a pulley or two pulleys. Okay, yep. And you know that magnetic board or board is enough. You will find the unknown mass. So simply you can write mass. You can also write hangers. Okay, you can split this two. This two goes together actually, mass and hanger. What else can you write? You can write string, or you can call it, sometimes you can call it rope, but rope is usually bigger. Okay, so fill the space with materials so that you have a bigger chance of getting points for the apparatus. Again, how many points will be there? It will be written if it is 1 point or 2 points or half. Yes, digital balance is also used, or you can use maybe just the word balance. Okay, now let's go to the theory. The theory, it will be given to you. Is that clear? The theory, or all the rules that you need to calculate, even from before we give it to all the students. That means that you do not have to memorize the theory. Well, what's the theory here anyway? The sum of all forces in X, 0. Sum of all forces in Y, 0. Sum of all forces in Z is 0. Or simply YZ equal to 0. Okay, that's one rule. What else? Finding the unknown mass, R, is equal to the square root of T1 squared plus T2 squared plus 2 T1 T2 cosine theta. What else? The finding the value for alpha, which is tangent raised to so many rules. You don't have to memorize them, but you must know how to use them. Okay, so in the exam, this part is not included. You don't need to memorize the rules. Okay, now let's continue. When you get this exam, the objects in equilibrium, my suggestion for all my students is that you start with, oh, sorry, wrong shape. You start with this, bus. Only this, okay? You start with T1, T2, theta 1, and theta 2. There is a reason for that, okay? Let's go to the picture of the setup and see our T1 and T2 and theta 1 and theta 2. This unknown mass is the steel, hadid, okay? You will find the value of this using a digital balance or a triple beam balance. You will measure it. And usually, this will go from the range of 95 to 100 grams. I cannot tell you the exact value, okay? So it's from 95 to 100 grams. Next, you will hang two masses, here and here, okay? No? 106 is the brass. The brass is 105 or 100 to 100 something, okay? Shabab, do not memorize the value of this. Why? Because each, even if you are given the same material, the final value will be different for each of them, okay? They are not exactly the same. Now let's continue. The two masses on the sides, you will hang them, is equal to 75 gram. That's the suggestion. You will use wahed, 50 gram, 120 gram, and the hanger, hadi, this hanger, is actually equal to 5 gram. This one here, that's equivalent to 5 gram. Many students forget this, okay? So the total is 75 gram. This is the best combination. What you must do to avoid mistake? Number one, the string must be on the pulley, here, okay? The string must be on the wheels, should not be on the back. Second, this mass should not touch the table, okay? If the two masses T1 and T2, this and this, are not on the same height, it doesn't affect the result. It doesn't affect the result, okay? What else? You should make sure that here in the center, the two strings are meeting in the center of the degree scale here. You can use your finger to move the string a little bit. Okay, you can adjust the degree scale because it has a magnet, but you can also use your finger to just all the three strings tied together, move it to the center. And you have to make sure of what else? This one here should be at 270. The string for the unknown mass should be at 270. This is very important. That way, you will be sure that your angle, θ1 and θ2, will be correct. Now, don't worry. In this case, θ1 is 41 degrees, θ2 is 140. Let me zoom in. How much is that? 141, 42, 43. Okay? θ2, 143. Don't worry that you will get somewhere different with θ1 and θ2. If one of them is different, the other one will follow. Okay? So let's go to our reading here and record the values. We know this is 75, 75, 41, 143. Any questions so far? Okay, let's continue.
Teacher, what's the 41? From where?
Oh, you have to observe. Did you arrive just now? This is 41 degrees here. Can you see this one here?
Where, teacher?
Here.
Yes. Yes.
That's the 41 degrees.
Oh, okay. Thank you.
143 is from here. Shabab, you have to focus, okay? You know one of the technique of passing the exam? Focus. Don't worry about who else is taking the exam, who is the proctor with you. You have to eat your breakfast or your lunch. Yes, go ahead.
T1 and T2 always 75?
No, you can use any value, but there are two things I want to tell you. Number one, if you use 75, it's easy. Both of them, if they're equal especially, okay? I'll explain to you when we go to calculations. Okay? Now, do not do just these, I should write it. No, you have to complete everything in the exam, okay? For now, you finish only this part, the one on the red square or rectangle. Do not do this one yet. No. But you can do this one with the balance. This one is not a problem. Let's say that it's 98, for example only, okay? For example only. We only need to make it move up. Move what up? You have to be clear with your questions, okay? So let's continue, Shabab. Once you have this value, θ1, θ2, T1, and T2, you go to step number 2. Yes, the unknown mass or the unknown force should be hanging, not touching the table. Okay? Again, Shabab, here's the technique in the exam. I hope you have your calculator with you so you can help me calculate. The idea here, again, once you have T1, T2, θ1, θ2, go straight to mathematical method and calculate θ. So, θ is 143 minus 41 is equivalent to what? Anyone?
102.
102. Excellent. Okay. So 102 degrees for θ. And then substitute. You get the square root of, like I said, you will have the rules. Okay. So 75 square plus 75 square plus 2, quantity 75, 75. Anyone can calculate with me cosine 102. So I'll try it in my calculator, or if you have scale it. Shabab, listen to what I'm telling you before you ask questions, okay? So 75
Teacher,
squared. Yes. What is it?
this resultant will there in the exam. The قانون.
Again?
قانون will be there in the exam. Equation.
The rules will be given. I don't want to repeat myself. Please, you have to listen carefully, okay? The rules will be given. The equations, okay? 94.39. Good. So let's write it here. 94.39. And then you move forward. Find the value of alpha. Okay? What is alpha here? Do you know how to use shift tangent in your calculator, Shabab? I hope that you know how to use shift tangent. Okay? That will give you tangent inverse. So let's calculate. Shift, tangent, and then quantity. There is a fraction. 75 sine 102 over 75 plus 75 cosine 102. This is where using 75 and 75 for T1 and T2 is important. Why? If we write here, okay, this is 75 sine 102 over 75 plus 75 cosine 102. I want to show you something, okay? If you, yes, Firas, thank you. If you use one side 70 and the other side, for example, you use different value, let's say 80 or 85, what's the problem? 70 sine 102 over, if you put it here, okay, 70 plus 80 sine 102. This value here is T2. Okay, this value here is T1. If you use T1 and T2, the same number, you can exchange them in the equation and it will not affect the result of alpha. So if you use this, it will not affect the result. But in the beginning, if you use 70 and 80 here and here, what's going to happen? You can use it, but the risk or the problem will be if you exchange them in the calculation, it will affect the result. So you want to use 75 and 75. If you want to use 80 and 80, fine. Okay, but the best way is 75. Even the fit in the graph paper, when you make the graph by hand, it will still be fitting nicely. Okay, so here you can write the final answer. I think somebody said 51 degrees. Now, what's the advantage of doing the mathematical method first? You will take maybe 5 minutes to finish this one. Aziz, stop asking now, okay? I will tell you what it will be. So first, focus on what I'm teaching you. Do not ask questions about, I'm not talking about it, not yet, okay? You have to focus on what I'm teaching you now. So here, again, once you finish, where's my mouse? Once you finish this part in your measurement, go to the mathematical method. You have the right to pick any part of your experiment final. Just like in the theory, you can go with multiple choice first. In the exam, the values will be the same? No. It depends on you. So you can use 75, 75. Maybe this one will be different. Okay? But what I can say is, you can use 50 and 50 as long as the object, which is the unknown mass here, is not touching the table. Okay? Now, let's go to the graph. Now, for the graph, Shabab, the best way, I will explain, okay? For the graph, the best way, F determine your calculator, maybe you're wrong. Check it again. The best way to do the graph is, of course, using the right scale. So now we will go to the scale. You are finished with the mathematical. Now it's time to go to the graphing, okay? We always use the best scale is 10:1. For every 10 gram, you get 1 centi. That means 75 divided by 10, 75 centi, or 7.5 centi, okay? 7.5 centi. So now you finish this part, we go to, too much. We go to this part here, so that you don't make a mistake in calculations, okay?
Teacher,
Yes.
how you find the scale and weight?
You make the scale. You make the scale, your choice. You can use 5, okay? 5:1. But is it a good scale? It's not a good scale, because here you take 75 divided by 5, what do you get? So you have to think. So it's 15 centi. Next, in the graph paper, do you think 15 centi will fit? 15 centi to the right, 15 centi to the left. So the best scale is always 10:1 for our equipment and our paper. Clear? So how do you make the graph? The video in the YouTube will best
Doctor,
explain. Yes?
what about 15?
What do you mean, what about 15? Again, like I said,
when I put 15 gram for 1 centimeter, not 10. 15.
Okay.
Is
Okay,
it gonna
let me
be
ask
good?
you. Let me ask you in 3 seconds. What is 75 divided by 15? 1, 2,
I don't know.
3. Exactly. Now ask me what is 75 divided by 10. In 1 second, I will tell you. 7.5. The
Oh.
idea of using a scale is
Will
to
be
make it
easy,
easy
huh?
to measure and calculate.
Oh, yeah. Yeah, I
Okay?
got the idea. Thank you. Yeah,
Now,
thank you.
why do you
Thank you very much.
want 7.5 centi? It makes a very nice size of a graph. Not too big, not too small. It will fit the paper nicely. Clear? So how will the graph look like? Now, it's very difficult to make graph using my digital pen, okay? So you can actually watch the video, which is in the GS department YouTube channel for the objects in equilibrium. And it is there, it is given there how to make the graph easily. You can review it. But the idea is like this. You will draw, okay, you will draw, come on, your T1 here, okay? Again, like I said, it's very difficult to make graph here. You will draw T1 here, and then T2 here, okay? Don't forget to label your graph, T1, T2. That's theta 1, and this is theta 2. Between T1 and T2, you get theta. Next, you will measure theta from here. So you will continue this with a small line, and then measure theta. This angle should go there, okay? And from that angle, you will make or transfer your T2. It becomes T2 prime. The angle theta prime and theta should be the same. From there, you will use your mascara to draw a line from the end of, wallah, this line is there and there. So that red line, of course you have to use pencil, okay? That red line is your R, and that R will be in centi. How much is that in centimeter? You have to measure with your mascara. You will go back and write it here. So for example only, just as an example, okay? Let's say that it's 9.5 centi. How do you change it into gram weight? Just like the scale, divide by 10, we do it in reverse. Multiply by 10, this becomes 95 gram weight, okay? Finally, what's the angle alpha? The slow method is to measure the angle from T1 up to R, that's the angle alpha, and you measure it using the degree scale. The fast method, which is helpful in the exam, you already have alpha, Shabab. How? This is your alpha, remember? 51 degrees from mathematical method. It's the same angle we are talking about, so just write there 51 degrees, and you are done. Well, at least for the calculations. Any questions? You see the advantage? If you do the mathematical method first, you will not get 0. Why? You have points from the number 2 question. And then you can do it very quickly. You spend most of the time, the remaining time, you do this for 10 minutes, mathematical. The remaining 50 minutes, you can do the graph. You can do the other parts of the exam, okay? So now, let's go to the other parts of the exam. This one is not included in the exam, okay? If you have this in the result, what does this mean? This means that just what's the result of your experiment, okay? Method 1 from the graph, it's 95. Method 2 by calculation, did we get a number by calculation? 94.39, okay? So 94.39. This is 51 and this is 51. Make sure your graph is perfect, okay? There's no method 3. Next, percentage error. You have to check the statement, the question in the exam. If it says only method 1, then you have to find percentage error only for method 1. So just make sure you have absolute value. What's the real value by balance? 98 minus 95 over 98. Multiply 100% and write your percentage error. Okay, done. If you have 2 methods, then you have to do both. So F real, don't forget. Maybe you were saying, teacher, where is F real? I don't know. You are the one who will measure F real from the observation. Any questions about this experiment? Somebody asked in the beginning, source of error and precaution. Source of error and precaution. Do not memorize source of error and precaution from the book, okay? You have only two types of experiment. The first type of your experiment in the finals is called mechanical experiment. The second type is called electrical. We don't have chemical or thermodynamics, okay? If your experiment is mechanical, the source of error is always friction, or you can say there is friction in the system. If your experiment is electrical, there is internal value, okay? Usually, you will write internal resistance. These are values that we cannot remove from the experiment, but we can reduce it. So in the precaution, if it is friction, just write reduce friction. How do you reduce friction? You put oil in the system. Okay? What about internal resistance? What is the precaution for internal resistance? Well, you can reduce the internal resistance also. How do you do that? You can reduce the internal resistance by using good cable or good quality cable, short cables instead of long cables. Okay? That's why some PlayStation, when you have the HDMI has gold. Why? Because gold has a very low resistance. That's the idea. Okay? There is only one experiment where it's not resistance, instead it's capacitance. So if the experiment is the parallel plate capacitor, let's go to the parallel plate capacitor. This is number 8, I think, or number 7. It's this one. No. La. Let me just scroll to it. This one here. Okay, number 9. So here, instead of writing internal resistance, because you are using capacitance in the source of error, you will write internal capacitance. And there is internal capacitance in the system, okay? Which experiments are mechanical? Well, which experiment don't require electricity? That's the idea. There is moving parts, okay? So let me highlight. The objects in equilibrium is mechanical experiment. What else? Velocity is mechanical. It's not in the exam. Projectile mechanical. Rotational inertia mechanical. Simple harmonic motion mechanical. As you can see, okay? What about the others? This is electrical, electrical, electrical. Reflection of light, this is waves and optics. What about Joule's equivalent of heat? This is thermodynamics, usually for chemical measures. So the idea, Shabab, if it is mechanical, you will do as a source of error friction. Okay, so this and this. These are the two experiments that are mechanical in the finals. Okay. So we've done objects in equilibrium. Wallah, it takes us half hour. We have to go faster because I have a meeting at 8. Let's go to the next experiment, okay? Rotational inertia. Now, in the rotational inertia, you are most welcome, of course. Rotational inertia, is it this one? No, that's projectile motion. It's number 5, I think. Number 5, there, okay? You know the objective. The apparatus, you should know it. Use the computer as well, okay? So what else? The rotary motion sensor, this one has a name. You will write the name, you will see the name on the device, okay? It's called rotary motion sensor. Now, this one, you will use only 2 objects. The first object is solid disk. The second object is mass and rod system. The ring will not be in the experiment. Clear? It's not in the experiment. Now, I want to explain to you something here. You will do only one of them, okay? I want to explain to you something here. How you can accomplish this experiment in the best way. The datasheet for this is missing. Let me go to the document file. 1 second. I didn't notice this datasheet is missing. Physics. Suggested for the final exam, lab manual. Let me just open the Word. Okay, so this is the Word file. This one is more complete. Rotational. I like to use the PDF because it's faster. Okay, here's the rotational inertia datasheet. Okay, again, I don't need to discuss the objectives, the apparatus, and the theory. Let's go to what you should do. Okay, number one, Shabab, you should be able to determine one thing here, the applied mass. You have to use 25 gram. Again, the applied mass has to be 25 gram. You have to convert it to kilogram. That means divide by 1000. The radius of the smart pulley is given 0.25. Are you sure? That's divided by 100. Gram to kilogram is divided by 1000. You have to be careful. Why? If you make one mistake in the conversion, everything else will be affected. Okay? The radius of the smart pulley will be given. Now, if I remember correctly, it's 0.0238. If I remember correctly. If not, it will be given in the exam. Let's continue. You will get only the disk. That's your experiment, your finals. If you get the, what do you call this one? If you get the mass and rod, that's your only final, nothing else. So you will do only one shape. Is that clear? Okay. The technique here, Shabab, is to start again with the theory. Okay? The technique is to start again with the theory. So what you should do is, let me go and take a screenshot of this one, and I will go with my OneNote, because my OneNote is much better than writing in Word. Okay, let's go with the disk, and let me go with my OneNote, and I will write a new section and paste it here. There you go. So here, what you should do is first measure the ring. Okay, when you measure the ring, I will tell you that the mass by balance is around 120 gram, plus minus 121, 120.5, 120.25, whatever it is, it's around 120 gram. Okay? You have to change it to kilogram, divide by 1000. What's the technique when you change from gram to kilogram? I will show you one technique. 1, 2, 0. Where is the decimal? Hena. If you divide by 1000, you have to move the decimal 3 times. Again, if you divide by 1000, you have to move it 3 times to the left. So how many times? 1, 2, 3. This will become 0.120 or 0.12. Okay? That's the idea of how you can get without dividing by your brain. Just move the decimal. Centimeter. The diameter, I will tell you, is 9.53. I'm quite sure. Okay? So how much is this in meter? 0.0953. Why? Again, 9.53 divided by 100. 1, 2. There's 2 zeros. 1 0 here, decimal there. It becomes 0.0953. Okay, that's the technique when you have to divide by thousands or by hundreds. Okay, I hope that will help you in the exam. Now let's continue. I lost my pen. Oh wait, I'm using OneNote. I have to use eraser. So let's continue. Once you have the diameter, you have to take the radius. Okay, so in this case, maybe you will need a calculator. Please bring your own calculator, because they will not allow you to share. You can share, but you get free Corona. So here, the radius 0.4765. Try not to reduce the number by dropping the decimal. Okay, keep the number whole. Yes, go ahead.
I use diameter in centimeter or meter in the radio.
You have to use everything meter and kilogram.
Okay.
Now let's continue, Shabab. My feet are getting cold. Well, I love this weather. But anyway, let's continue. What's going to happen next? Do not get the slope. La. Do not get the slope. Not yet. Okay? You have to focus on the theory part. Why? Because you already know, Hamza, why you keep raising your hand? You already know, you can already calculate the theory part, okay? So from here, I will draw a line to separate the theory with the, what do you call this one? With the experiment value, okay? So let me draw a line so I can separate the theory and the experiment value. So from here, calculate the theory. Don't take the slope, not yet. So when you calculate the theory, 0.5. Where is 0.5? 1/2. Okay. Multiply by mass. How much is mass? 0.120. You can write here kilogram. And then the radius, 0.04765. This is meter squared. Calculate this one, please, okay? I will not write the answer anymore. But the unit, if it is given, good. If it's not given, you have to write it, kilogram meter squared. Kilogram meter squared, okay? Next, once you have the calculation by theory, then you can focus on the experiment. What I can tell you,
Teacher,
2.85 by 10 minus 3. Are you sure, Mohammed? Yes, what's the question?
from where you get the value for the radius?
This one,
Yes, from where?
diameter divided by 2.
You mean 0.0953?
Yes. Yes.
Okay.
Did I make a mistake? It's okay. If I make mistake, tell me.
No, I just want to know how we get this.
Aha. Okay. Listen more carefully then. I just told you that. Let's
Okay.
continue, Shabab. So once you finish the theory, what's the advantage? You already have points. Again. So what do? You go to the experiment. You put the disk on the rotational device. Before you switch on the software, you have to make sure that Shawarma, you are playing Among Us. We should play sometime. I got distracted by this guy. It's okay. Place the disk before you open the software. You must make sure the interface is on. Before you turn on the interface, Shawab, you must make sure that it's plugged in to the power. It needs power to work. Okay? So from there, what are you going to do next? Switch on the interface and then open the file and then place the disk, do the process. You can watch the video how to do it and then find the slope. If you are using the disk, the slope is anywhere around 36. If you are using 25 gram as the applied mass. Okay, where's the applied mass? You go back to the data sheet. Go to the reading for the applied mass. Oh, it's not here. I'm sorry. We are using Word. Okay. For the applied mass, 25 gram or 0.025 kilogram. Okay. As long as you are using that value, you will get a slope of around 36, 36.5, 35.8, any number. Okay. Because the friction affects the slope, so it will not be an exact number, but it will be around 36. If you get around 36, you are sure that your slope is good. You have to write it on the paper and the teacher will check it for you, okay? Next, once you have the slope, you can calculate now the inertia by experiment. This is what I will tell you important, okay? The mass and the radius in this theory, in this equation, is not the same as the theoretical value. Is not the same. Okay? That means the measurement of the disk, Hadi, the measurement of the disk, mass and radius, you will use it, sorry for the scrolling is too fast, you will use it only for the theory. The measurement for the slope and the measurement for the torque, this one here, you will use it for the experiment value. Clear? So go to the experiment value and we will calculate. So you say, where's my pointer? There it is.
Teacher?
So you have to write MGR, Ewa.
Where we will find this recording?
Again, your question is not clear.
Where we will find this recording, this session?
I already answered that question. Just wait, okay? We will give you.
Okay.
Please, if you have questions, focus on the topic so that we don't get lost. Let's continue. So again, the slope will be used for this, okay? Only for this. And the mass and the radius, how we get the mass? Which mass are you talking about? The disk or the experimental value, the applied mass? How you get the slope? From the software. How you get the mass? Which mass? Mass of the disk or applied mass? From the balance. You have to listen. Again, Shabab, you have to listen. If you miss anything because of bad signal or you are late, everything is recorded, okay? We will lose time and we will not be able to finish all the experiment. You have to listen. Again, this is slope, should be your slope near this number. Near this number. I'm not saying that this is the perfect slope. I'm saying that whatever you find in this experiment, this is the slope. So let's go by theory. Mass 0.025. Not this one. Why? Because here mass of the applied mass causing rotation. Okay? Multiplied by gravity 9.8 meter per second squared. Multiplied by radius of the pulley 0.0238. This will be given over the slope 36 minus the same mass 0.025 and the same radius, but this time you have to square it. 0.0238 meter, you have to square it, okay? Squared. From there, you can see that the unit will become meter squared and it will become kilogram meter squared, okay? So the idea again, Shabab, you will use the torque values here at the bottom and you will use the disk value at the top, okay? Any questions about the disk? Source of error precaution, I already gave you the idea. Let's go with the ring. Sorry, not the ring. Let's go with the mass and rod, okay? Mass and rod. So in the mass and rod, let me take a screen capture of it so that I can go and write. Okay, go to the note, new section, and stick it there. Hey, that's too small. 1 second. There you go, and stretch it. Okay, for the mass and rod, you have to understand something. What is that? The equation will not be the same. So in the exam, we are giving you all the rules, but if you get the two rules, one for the disk, one for the mass and rod, you have to know which one you are using, okay? For the mass and rod, the inertia by theory is different. It's m1 d1 squared plus m2 d2 squared. Again, I will tell you that mass 1 is somewhere around 75. You have to measure the exact value. It's not exactly 75 because of dirt or something. So this become what? 0.075. Mass 2 is also around 75. So 0.075. Distance 1 is 18 centimeters. Muhammad Al-Ajmi, you are using values from, I think, maybe the YouTube video. So you cannot use the exact value. You have to use the value in the exam. The one in the lab, okay? Because the teacher might ask you to get one mass, go to the balance and record it. He can check if you are memorizing value or you are doing the experiment. So D1, D2 is 18 centimeters. Shabab, 18 means from the center here up to the center of mass, not the edge. Not from the edge, the center of mass. Clear? 18 centimeters divided by 100, that means 0.18, 0.18. These two values are constant. You use Mastara, yes, but this is constant. That means this will not change. This one will change, maybe by small amount, but the masses will, the distance will not change. Okay? Again, do not do the slope, not yet. Instead, calculate. So you will calculate, sorry, it should be in kilograms. So 0.075 multiply 0.18 squared plus 0.075 multiply 0.18 squared. From there, write the inertia. Then you go to the rule for the experimental, okay? The value for the experimental, you need the slope first. If you have the rod or the masses and rod, the slope is always 1.0 something. So in this case, maybe it's 1.05, 1.08, 1.02, 1.04, always this value, 1.0 something. Clear? Is that clear? It is always this value. So the idea now is that you have to take only the slope. The rule for the inertia is the same, which is what? Torque over alpha, which is what? mgr over slope minus mr squared. So what is the mass? 25 gram. Change to kilogram, 0.025. The rules will be given. How many times do we have to repeat that? 9.8. What's the radius of the pulley? Will be given 0.0238 divided by the slope. So in this case, from the disc or from the rod, you will only change the slope in the equation, okay? Minus mr squared, the same mass, 0.0225, 0.0238 squared. All the as this or in the end of the paper. I will not tell you. How did you get 1.05? I've been doing this experiment for 14 years. It's always the same result. 1.0 something, okay? 1.0 something. Always you will get. If the mass applied is 25 grams. What is the applied mass? Let me go to the image of the experiment. The applied mass is the mass that is hanging from Hadi. This is the, maybe I can insert a shape here. That one. Oh, it will cover it. I hate working with Microsoft Word. That one. That's 5 gram. 20 gram plus the hanger is 5 gram. Clear? Any questions about this experiment? You have to do percentage error just as the others. Okay? Let's go to the next experiment. So the next experiment, yes, including the mass holder or the hanger. Okay, including the hanger. So just use 25 gram by default. Okay, let's go to the next experiment by scrolling down. Simple harmonic motion is not in the exam. Resistivity. Okay, resistivity. Let's go to this experiment. So page width. Oh wait, I have this in PDF. So in the resistivity experiment, those who are asking the same questions either late or not listening, you will get 2 options here, but the choice is not from you. Clear? You will get 2 options, but the choice is not from you. So here, what are you going to do? If you get 4 wires, arba, that means resistance versus 1 over D. If you get only 1 wire, wahed, that means resistance versus length. Is that clear? Is that clear? Oh yeah, did I say 1 over D? Sorry, that's capacitance. My mistake. This will be resistance versus 1 over A. Okay? You have to connect the circuit. There is a technique of connecting the circuit. Watch the video. It is there. If you know it, some of my students, I showed them you can connect the circuit even with your eyes closed. Okay? It is possible. So let's go with the first experiment. 1, resistance versus L. No need the objective and the others. 1 experiment from 6 will come. Which is number 6? Simple harmonic motion? La. 2. 1 by disc and 1 by mass and rod. So let's go with the experiment directly with the reading. If you get only 1 wire, for sure it is copper. Okay? If it is one wire, for sure it is copper. And try not to complain and say, teacher, the diameter is not given. Okay? The diameter will be given for you. So if you have only one wire, it is copper. If you have 4 wires, 1, 2, 3, 4, that means you have brass. And the length is given, 24 centi. Clear? Shabab, focus. Now, what do you do here? Always keep the current one. Always. Wahed, wahed, wahed. Always 1. How can you find the slope in this experiment? The rules will be given. Let me show you. Okay? You will measure the voltage. Now, I cannot show you the voltage now. There is an existing value in your data sheet. But what you know is, by Ohm's law, the resistance is equal to voltage over current. So any value here, for example, this is 5.1, okay? 5.1 divided by 1, the same value as the resistance. Shabab, please focus, okay? How do you know? Because I'm going to tell you the technique of how you will determine some things that are important in the exam. Go to the calculation. If you have the copper, that means you will have only calculation number 1. This one which I put inside the rectangle, the red, okay? The first thing you must do is calculate the area. Once you have the area, you can proceed with the graph. Once you have the area, in table 1b, we are not in table 1b. I will answer that when we go there, okay? How do you know when you have to make a graph? It says here, find the slope from the graph. Definitely. But what is the graph going to look like? I want to show you the technique. If you are given the statement, find the slope of R versus L in this graph, the first value is R. This is always y-axis. The second value, which is L, this is always x-axis. Always. Any experiment, okay? So that when you make a graph, R on the y-axis versus L on the x-axis, this graph should go straight to 0. This graph should go straight to 0. The rule for the slope is the same everywhere. The slope is actually equal to delta y over delta x. The easiest way is to take your point, for example, 5.1. This become my resistance, 5.1. I know this is my y and this is my x. When I find the slope, I will take delta y over delta x, which is equal to y2 minus y1 over x2 minus x1. Look at the slope, Shabab. Look at the graph. It goes to 0, and 0 is also a point. So you can use any number, not even the biggest one, any number, okay? In this case, I will take, for example, 5.1 minus 0 over, what is the value here? 24 minus 0. 5.1, 24. So you get the idea, Shabab? You can do minus 0. Why? It's easy. So once you have a slope, in the graph, if you want to perfect the exam, you have to write the unit. This is milliohm, and this is centimeter. Therefore, your slope will become milliohm over centimeter. Now, there is a trick. There is a trap in this part of the exam. This is times 10 raised to minus 4. Times 10 raised to minus 4. But it's also milliohm. You have to remove milli. So you have to multiply times 10 minus 3. You get the idea? Times 10 minus 4 and times 10 minus 3. 1 second, because my Blackboard is closing. Okay. So the idea here is that you have to combine these two so that this will become minus what? Whatever it is, minus 4 and minus 3 become minus 7, right? So this become times 10, whatever is the number, minus 7, because minus 4 and minus 3. Shabab, do you get the idea I'm telling you here? So that the unit will be ohm over centi. Okay? What's the importance here? If you go later on to find the real value, you will see that the unit should be correct.
So
So
teacher,
the idea, yes, go ahead.
to make it ohm, I have to multiply 10 with the power minus 7, correct?
Minus 3.
Minus 3?
I will go back. I will go back, okay? From the beginning, please focus. I will go back so that you can determine what I did. Oh my God, I cannot delete. Okay. When you find the slope, it will be milliohm over centi. Is that clear? And the value of the slope, is times 10 minus 4. You have to remove milli. So how do you remove milli? The slope as a whole, you have to multiply 10 minus 3. You can divide by 1,000. Yes. But in this case, times 10 minus 4 is an exponent. So the easiest way to divide this number by 1,000 is simply take minus 4 plus minus 3. So that this becomes times 10 minus 7. Because you do that in your mind. You don't need a calculator. Clear? In that way, you will have the slope times 10 raised to minus 7 ohm over centi. Why is that important? Let me show you. When you calculate the resistivity, you will multiply ohm over centi by centimeters squared. This will cancel centi here, and this will cancel squared. Yes or no? The final unit will become ohm by centi. If you go to the back of your book, the real value for the resistivity, what's the unit? Ohm by centi. And this value is for copper. For brass, here, is also ohm by centi. These numbers will be given in the exam. You have to know which one is for you, copper or brass. Clear? Is it clear?
Yes, teacher.
You have this number at the back of your book. Okay? Now, Muhammad Al-Ajmi, what's your question? Abdulaziz, what's not clear? Tell me quickly. We already reached 1 hour. I can give you an extra 15, maybe 20 minutes. What is not clear, please? If it's not clear, my suggestion is you review the recording. Okay? Again, the last part I'm explaining to you, because it's clear for others, that means they understand it. I'm explaining to you how you can change from milliohm over centi to ohm over centi, and why it's important. Okay? So you can study the review. Don't worry, you can review the recording. Let's go to table number 1B. In table number 1, do you have to change always? You must. Everything is not clear, Khalid? Maybe you didn't have breakfast. Let's go to table 1B, okay? If you get 4 wires, that means, I hope I don't forget it. Wallah, I'm not trying to remember anything. If you get 4 wires, that means you have to do resistance versus diameter. You need to arrange biggest to smallest, 1, 2, 3, 4 on the table. Why? So that you will not make a mistake in the reading. Okay? The current should remain 1 for each of them. That means once you set the current, bus, don't touch it. What's next? You can go and calculate the area immediately, or you can calculate the area last. It doesn't matter. Once you measure the voltage, okay? Once you measure the voltage, you have to record it here, and the voltage will be increasing. The first one may be around 13, the last one may be around 88, something like this. Should be increasing, okay?
How can we measure
Calculate
it?
the area. Yes?
How can we measure the voltage?
How you can measure the voltage? Watch the video in YouTube. You have to connect the circuit. Once you connect the circuit, you have to set the, I don't know how to get all these numbers. Wallahi, that means you don't know how to do the experiment itself. You are sleeping in class. Watch the video from YouTube, okay? You have to keep the length 24 centi. You do not change the length of this experiment. Okay? You don't change the length. You keep the length 0, 24. Where? In this device, the resistance apparatus, the name is there if you need it. Okay? In this device, you have to keep always 0 and 24 for table 1B. For table 1A, there you change the length, 20, 16, 12, 8, maybe 4. But in, what's your name in you? I will give the link to my students and you can share it. Okay? If you memorize the number, will you get full? If you memorize the number, you are stupid. Why? Because maybe you will not even get the same experiment in the finals. Okay? Do not memorize the number. So here you will get in the voltage meter. But this one is wrong. This should be in millivolt. Okay? This should be in millivolt. Should be here. It should be in millivolt. Okay? Why it should be in millivolt? Why should it be in millivolt? Because the numbers are very small. And you have to press the yellow button to make it DC. Don't forget that, okay? Shabab, I have seen many students memorize the number. You know what happened? I will tell you what's happened. He get the resistivity experiment. He memorized the number. And then what did he do? He take the number for this and he place it in the wrong table. Because the setup is the same. Did he get full marks? No. He got almost half mark only. In the observation, he got 0. Did he memorize the correct number? Yes. How did I know? Well, I will check the paper. Okay? It's not a good idea to memorize the number. Why? If you work for SABIC, you forget to change the setting in the device. La. Why do you forget? Why would you forget it? Okay? Shuf. In the experiment, the voltage should be in millivolt. That means you know you will dial the voltage to millivolt. What else? The current should be in ampere. Let's go to the device. Where you will measure the current? In the digital meter. Let's go to the digital meter. Okay. Is this correct for the current? No. This one is wrong. This one is wrong. What is the correct one here? It should be in ampere. Should be like this. Why? Because you are measuring ampere. And how do you know you plug it in the right board or in the right hole? That's A. If you are measuring voltage, you will see here V. Okay? So you should not make a mistake. This is the easiest. Wallahi, Badr, I told you this. Some of my students, go and ask them. I don't know if somebody take video. I hope not. I connected this circuit with a blindfold, with my eyes covered. Okay? Now let's continue.
Teacher,
Yes, go ahead.
what's the difference between schedule 1A and table 1B?
What is the difference?
Yeah. Yes.
Everything.
How do I know?
How do you know? I told you this in the beginning. If you have one wire, you will do table 1A and you will see it there. If you have 4 wires, you will see table 1D in your exam paper. You will get only one table. Okay?
Okay.
Is that clear? Even for Salah, is that clear?
Yes.
So how about the process? How do you know if you have to change the length? Simple. Can you change the diameter if you have only one wire? You cannot. That means you have to change the length. If you have 4 wires, you can change the length. But because you have 4, that means you have 4 different diameter. You have to do by diameter. You keep the length constant. Okay? Yalla, let's continue. We are getting delayed. Calculate the area. This is the rule for the area. You might ask a stupid question. What is that? Teacher, how can I calculate the area? I know pi, but I don't know what is the diameter. You have the diameter. There, look to the left. That's the diameter. That's the D. That's the D. Everything you need in the exam is on your paper. Okay? All the diameter is there. Don't forget, you have to square it. You have to change it into meter? La, because the unit is given. It has to be in centi. Okay? Next, what about 1 over a? Use the inverse in your calculator. Find the button in your calculator, x raised to minus 1. That's the inverse. Okay?
Teacher,
Or you can take 1 divided by a. Ash?
this centimeters square.
Yes,
have-
centimeters square.
You have to make
Because
the. You have
no,
to make
you
it.
have to apply the formula.
Okay.
What's the formula? Simple. 0.25, that's 1/4, multiply pi in your calculator, or you can use 3.1416, multiply by d. So the first one, 0.13 squared.
Okay.
Okay?
Thank you, teacher.
Easy peasy, lemon squeezy. Let's continue. Once you have 1 over a, you take the value of r. Again, the value of r is the same as the voltage because we are dividing by
Teacher.
1. Yes?
Where is coming the 0.25? Okay.
Is that clear?
Yes.
Let's continue. Once you get your resistance and your 1 over a, it's time to graph. Let's go back to the calculations. So now we will go and bring our square down here. Okay, it says from table 1b, you have to make a graph of resistance versus 1 over a. I already told you how you can get the x and the y. This is your y, and the second number is the x-axis. The graph will also go, okay? So you have resistance 1 over a. The graph will also go to 0. That means to find the slope, what's the rule for the slope? Delta y over delta x. You can simply get y2 minus 0 over x2 minus 0. Okay? Your slope will be, again, milliohm by centimeter squared, because that's the result of the calculations. Okay? You have to remove milli by 10 raised to minus 3. Whatever it is. For example only, let's say that your slope here is times 10 raised to minus 2. So you will multiply 10 raised to minus 3. This becomes times 10 raised to minus 5. For example only. That's how you remove the milli from the milliohm to make it like this. Okay? Is that clear, Shabab?
We multiply by 10 to minus 3, teacher.
Yes.
Okay.
I already explained this one, how you can change from milliohm to ohm. Okay? That's why it's important to identify which one is your metal. If you have one wire, the color is red, it's copper. This is the real value. And look at the unit, ohm by centi. What I should write in Y? Wallah, I gave you already that number. Go and review the recording, okay? We are extended too much already. I want to finish everything for all students. Let's continue. So if you have 4 wires, color is yellow, this is the real value. Ash, yes?
We will give you this number in the final, yes?
They will give you all these numbers, so you have to know which one is for you. Let's go to the next experiment. So how do you know which one is yours? Look at your paper. Hena, Shuf, hello, there. Oh, copper. Can you see that? Copper. Hena, brass. So from the table, from your own paper, you will see what is the material. Clear?
So basically, sir, if I got one wire, it's copper. If I got 4 wires, it's brass.
Exactly.
That's it. Okay, thank you.
Let's go to the capacitance experiment. In the capacitance experiment, you will find, yes?
For the B determined unit, it will be ohm square or what?
let's go back. You are asking for rho, the resistivity,
Yes.
right?
Yes.
Okay. The determined value should follow the same unit as the real value, ohm by centimeter.
Oh, okay. Thank you.
And this is the real value there, okay? That's the unit. Let us go to the capacitance, okay? Is this the last one? The force balance is the last one, I think. Now, the capacitance experiment is actually quite easy if you know what you are doing. You simply need to find epsilon, and there's a trick here, which I will teach you later on, okay? This is a secret with me and my students, but I will teach you this. It's not a trick. It's a mathematical genius, actually. This part is not included in the exam. This is not in the exam. Only table 1. So let's go to table 1, okay? First, start by measuring the diameter of the capacitance plate. This one is fixed, 17. Oh, what happened to my pen? 17.7, or by meter, 0.177, okay? Next, the separation distance. If the plates are closed, it's automatically 1 milli. You can start from there. If this space in the exam is blank, go with 1 milli. Clear? But then 2, 3, 4, 5, 6, and 7. Let me open the capacitance experiment video, because I want to capture the graph from that video. Capacitance, physics, final video, capacitance. Okay. Yeah, keep quiet, Mr. Tim. We just need the graph. Okay. Okay, so this is the graph. Let me move away, take a screenshot, and I can go to my notepad. Okay. Now, you will notice that if you review this video, I actually made one trick for, well, it will affect all students. Because this trick is, there is one graph, one point in this graph, which is a mistake. Okay. So here you go. These are the points. Now, which point is the mistake here? It's actually this one. This one is the mistake. Is it 3? No, it's 2. Yeah, 3. Because we start with 2. This is 2, 3, 4, 5, 6, 7, 8. Okay. When you make a graph, it's important for the capacitance that you have to write the unit here. Nanofarad, that means times 10 raised to minus 9. And the unit in the x-axis is, of course, meter raised to minus 1. Okay? Now, here, the trick, Shabab, is that first, let's go first to the data sheet. Fill all the information. Okay? This is the millimeter value. In meter, divide by 1,000. So 0.001, 0.002. If you say, teacher, can I write can I write 3 over 1,000? You cannot. This is not a correct number. Why? It is not final result. Okay? It's an improper fraction. So you have to simplify 0.003. It's easy until 0.007. Okay? Can I use 2, 3, 4, 5, 6, 7, 8? Yes, you can. You can use 3, 4, 5, 6, 7, 8. Sure. Can I use 5, 10, 15, 20? It will be too big. Okay? The gap for the capacitance will be too big.
So
From
can
here,
I
yes.
make distance 2, 4, 6 like that?
No, I suggest keep the distances small. Okay?
Okay.
What is the important part that you need to know when moving the distance? Let me go and show you the scale. Now, the good thing about online with the video is that we can zoom in to the scale. Can you see the scale here? That's the capacitor scale. Okay? I will go with my OneNote and paste it there. So this is my capacitance scale. Okay? Now, many students are asking, should I start from 0? La, that's a mistake. Okay? Instead, you should start from where the capacitor is pointed. So in this case, where's the capacitor pointed? from here. Can you see this point? That's 1.7, right? When you close the capacitor plate, that means the minimum distance, this is equal to what? 0. Or this is equal to 1 millimeter. So if you are starting from this point, 1 millimeter, that means if you want to measure the next point, 2 millimeter, just imagine this plastic. There is a small line in the middle. It's pointing at 1 milli. If you want to go to 2 millimeter, just move. Okay, Tagiga, it's very hard. Just move from that point to this point. That becomes 2 millimeter. No, if you start from 7, it's 7 millimeter. La. If you start from anywhere, that's 1 millimeter, as long as the capacitance plate is closed. And then move one line, 2 millimeter. Clear? And then you will move again one line, that becomes 3 millimeter. So you will actually move a very small number of lines. This is 4, 5, 6, 7 milli. So this is 1 milli. Oof. Can I redo? Yeah. Sorry, because it's hard to draw. This is 1 milli, 2, 3, 4, 5, 6, 7. Wherever you start with the plate closed, it's equal to 1 milli. You don't have to start from 0. Okay? Clear? Now let's go back. Once you have all the reading, how do you know, by the way, if you have a good reading? I will tell you one thing. If you start from 1 millimeter, okay, you should get a reading of 0.3 something higher. If there is none, then you can, so for example, when I start from 2.2, it's 1 milli. Okay, let's go back. If you start from 2.2, let me erase all this stuff here. You close the capacitor, okay, and then the small plastic is at 2.2, hina, with the highlight of yellow. That's 1 milli. Where is 2 milli? Go to the next line. But then 3, 4, 5, 6, 7 milli. That's the idea. Clear? Can you do it by 2s? Yes. 1, or you can start with 2, 4, 6, 8, 10, 12. But like I said, the farther the capacitor is, the smaller the value, and it's not good for the result. So in the graph, it's the same technique when you need to find what we call y-axis and x-axis. Go to the data sheet, and it says there, you have to graph capacitance versus 1 over D. The first value, again, y. The second value equals x, or goes to the x-axis. The graph looks like this, okay? Now, here's the technique, Shabab. You can calculate the slope, but the graph is not always a straight line, and that's a problem. That means you don't know if your slope is perfect. There is a way to determine the perfect slope. How is that? Let's go to the data sheet, okay? In my case, the graph is actually quite good, but if we go to the data sheet, this equation is the technique of finding the perfect slope. This equation is to find the epsilon by calculation. Sa? Ikaw, Hadi. So how do you find the epsilon by calculation? The slope of your graph divided by the plate. But if you reverse this equation, you can find the perfect slope. We know that epsilon, the real value, is 8.85 by 10 raised to minus 12. If you cross multiply epsilon multiplied by the area of the plate, you will actually get the slope that is perfect. How? You know what's the area of the plate. You calculate it before you make the graph. There. And you know what's the epsilon. It's given. Epsilon, 8.85 by 10 minus 12. If you do this, the perfect slope should be somewhere around 2 point something. Okay, I don't remember the exact value. What do? You should write this perfect slope as the slope of your line? No. Why? because in that case, the teacher, if it's me, I will go to your graph and I will check your calculation for slope if you get the same answer. If not, that means there is something going on, okay? So once you know what is the slope, go to the table, calculate the slope for this, okay? Number 3 and maybe number 4. Why? If your slope is near the perfect slope, then you can use it to draw the straight line. If not, go to another number and calculate the slope. That's how you will find which point will give you the perfect slope. In this case, it's actually from here, okay? It's actually a different line. This line is not giving a good slope. It's actually giving something like 3. I'm not sure, 3 point something. So let's go back to the data sheet. And I hope to finish with the other one, maybe 5 minutes or something, okay? 2.17, it's near from 2.8. Yeah, I think the perfect one is, yeah, it's 2 point something, okay? I'll not tell you. Whatever is your slope, so 2 times 10 raised to the minus, let's say, you will get minus 4, okay? This is nanofarad. You have to cancel nano. That means times 10 raised to minus 9. So that the answer, 2 by 10 raised to minus 13. Okay? Why is this important? Because once you take this slope and divide it by the area of the plate, you will get a very good answer for your epsilon and find percentage error. Any questions, Shabab? So the capacitance, the secret is finding first good measurement for your capacitance and then finding on those measurements in the line of your graph what is a good slope. One last thing. The graph for the capacitance will not go to 0. You see where's the y-intercept? 0.05. You know why the y-intercept is 0.05? Do you know why? I will tell you the secret. Okay? The internal capacitance, source of error, I gave you in the beginning. Look at the meter. Before you connect it, there is already internal capacitance, 0.055. Before I connected it. Once I connected, look here, the connection is there. Okay? What's equal my slope? No, Muhammad Al-Ajmi. No, you didn't get it. The E that you will calculate should be near 8.85 by 10 raised to minus 12. The real value is given. 8.85 by 10 raised to minus 12. Okay? Your slope should be 2 point something. Let's go to the last experiment. I'm getting hungry. This is the last experiment.
Teacher,
Okay? Yes.
how can
Yes.
I get the area of flat?
The rule is given. Why you should ask that? That's the rule. Okay?
Oh, okay. Thank you.
Again, Shabab, this exam that we are giving you is almost perfect. That means you will not find any mistake. Everything you need is there. Okay? Let's go to this experiment. You will do only table 1. You have to understand the circuit because you have to connect the circuit for the loop. This is the circuit for the loop, okay? Now, watch the video which I did in YouTube. You'll find it in GS department channel. You should have the link in your Blackboard. All the videos will be there for the exam, okay? You will connect this wire here. You will connect this wire here. And this meter here, okay? I have a very good video which you can find. Now, let's go to the experiment itself. In the experiment, you will do only table 1. There is an example of a graph. This is the graph, the example of the graph that you should make with your hand. X-axis, IL, Y-axis, force. Okay? Clear? This graph is in your book. So let's go to table 1. Of course, you have to measure first M original by balance. Before you do that, all the power and magnetic field must be off and the circuit must be connected full. The Tesla meter will give you the B, magnetic field strength. The unit, the Tesla meter has the unit millitesla. Where is the Tesla meter? You will not find it here. But that device, I just dropped my mouse. Sorry. That device looks the same as the power supply, like this. There is a screen with a number and the unit says millitesla. That's the magnetic field B. You get that value once you switch on your magnetic field by the switch, okay? The IM, if your voltage in the power supply on the right side, on the dial. Hina, 1 second, I'm clicking the wrong screen. I want to show you the power supply, okay? You will control the voltage here. In fact, you will just go maximum. And the current here go 1 ampere, okay? But this power supply is for the magnetic field with the switch. If this is 12 volts, your IM, so if this is 12 volts, your IM should be 0.8 something. Clear? If this is 10 volts, that means it's lower. Your IM should be lower, around 0.6 maybe, or 0.5, okay? So let's go back to the table. It's not important, the IM. You have to put it there, but it's not important. Why? You will not use it in any calculation. Instead, IM is actually important in table 2, but you will not do table 2 in the exam, okay? Only table 1. So once you have M original, you do not memorize. Again, somebody asked, if I memorize the number, will I get full marks? No, you will get bad marks. It's stupid to memorize it. Why? Maybe it's 35 now. Maybe it's 35. La, in some tables, you know, they get 40. Okay? If you change...
37.
No, it's not always the same. That's what I'm telling you. Some table, they will get 33 or 38, 34. It's not always the same. And if you move the base, you see this tall metal here? This one here? If you move this, the value here will change. The dial here will change. The pointer will change. Okay? So again, for example, this is 35. Set the current to 1 ampere, and what you get here, okay, when you increase the current from your power supply, what you want is that this should go down and this pointer should go up. If not, you take the blue and the red cable here and you exchange them. Only these two cables. You exchange them, okay? Now, once you have the value of the dial, once you have the value of the current, you have to adjust the dial to point to 0 again to balance it and take the reading. So let's say it's 35.75, for example. And then this one is 35.80, okay? 35.82, 35.84, 35.86. I will tell you something. The change here should be almost the same. If it goes down, we have to adjust the balance, yes. Okay? So the value from 1.5 to 3, 1 by 1, should increase by almost the same amount. Not perfectly, but almost. Except for the value of 1. Why? Because for the value of 1, it's starting from 0 to 1. But here, it's increasing by half, by half, by half. Clear? Now, calculate the magnetic force F. You take the value from the left, 35.75, minus the original. 35.8 minus the original. Always minus the original. Clear? You will graph, again, by the same method. You will graph, what does it say here? F versus IL. How you can read the balance? Watch the video. F is the first value. That means it's the y-axis. IL is the x-axis. Always like that. Okay? You have to find the slope of the graph. Now go back to this graph. Like I told you, this is the graph that you will make. It looks like this. Okay? Is it perfectly like this? Maybe yes, maybe no, but it should look like this. And it should go to 0. So to find the slope, you couldn't get it? You should have practiced during revision. To find the slope, delta y over delta x, you can actually take y minus 0 over x minus 0. Teacher, which value of y, which value of x? Take any value of y, let's say 40. What's the equivalent value in x? 4. For example only, okay? Once you have the slope, you will take that slope, divide by the length. It is given 0.05. You will get the value of b by calculation. Do percentage error. Now many students are asking, what's b? Teacher, where can I get b? You already have b in the beginning from your Tesla meter. That's the real value. Any question?
Teacher,
Yes?
M initial and the P and the IM. This is this we have to do it when the everything
Of course,
is
you have
off.
to measure it. You have to measure it.
When everything is off, we measure it.
The only thing you will measure when the circuit is off is mass original.
Just this one.
Of course, how can you measure B or the current if it's off? Like I said, go to the Tesla meter and that's where you will find the magnetic field B. Okay? When you switch on the switch here, down here, of course the B will be displayed. Any questions?
How?
Shabab, I'll give you 5 minutes for questions because I really have to go.
Teacher, can you repeat how can I find M organic?
M original?
Yeah.
Connect the circuit without turning on. Yes, we are done. Anybody can leave anytime. This is recorded anyway. Turn on the circuit. Connect the circuit without turning it on. But then you have to balance here to 0. Whatever is the value, that's the M original. Okay? How to get the link? I will send it to my section.
Teacher,
You have to ask the link from the other sections. Okay?
teacher,
I will upload it in YouTube. I will.
error, mister.
Huh?
Can you repeat the percentage error?
Percentage error. Okay. No, if you are not in my section, I will give them the link. And from their link, I'm recording this only for section 48. I will give them the link. I will upload it in YouTube. Once it's uploaded in YouTube, then you can see it. Clear? Now, I will go back with the percentage error. You have B by calculation. Clear? This is B by calculation. You have B original. Where is B original? At the top of your table. That's B original. Okay? That's where you will calculate percentage error. Simple. Any questions?
so teacher,
Yes.
we have 6 experiments and one of them will come, right?
You have 6 experiments, but you have 10 sets. That means some experiments will be doubled.
What does that mean?
Check. Your teacher gave you the list of all the experiments. Is it 5? Yeah, I think it's 5. Yes, it's 5.
Yes,
Your
it's fine.
teacher gave you the list. Your teacher gave you the list of all the experiments.
Please, teacher, request if you can upload this class in YouTube today, if you can, because I have exam.
I told you I will stay up at 9. I have to wait until Blackboard will upload it. The fastest way Blackboard will upload it is if we stop now.
Yes, of course.
Okay? I will stop the recording now so that the upload will